Hello viewers, welcome to our YouTube channel Incredible Max. In this video we will see the concept of trace of a matrix and its properties. So first we will see the definition of trace of a matrix. So the trace of the matrix is usually defined for square matrix. It is defined for square matrix. So we will see the definition. So trace of the matrix definition is, let A be a matrix of order n by n, or we can write as n, then trace of a matrix A denoted by trace of A is the sum of all entries in the leading diagonal of the matrix A. So clearly we can see that trace is defined only for square matrix and trace cannot be defined for non-square matrix. Suppose the matrix A is of order n by n, so that is A is equal to Aij of order n by n, then trace of A is A11 plus A12 or A22 plus A33 plus etc. The last entry will be ANN. So here we note that trace is not defined for non-square matrices. Next we will see the properties of trace of a matrix. Properties. So the first property, so before going to the properties, so let us define the matrices A, B. If A, B, C are square matrices of order n by n, then the following are true. The first one, trace of A plus B is equal to trace of A plus trace of B, and the second one, trace of some scalar k into A equal to k times trace of A. So the first two properties are together called as linear property. So the trace is a linear property. So third property, trace of A transpose is same as trace of A. And the fourth property, trace of AB is same as trace of BA. So note that A and B are square matrices of order n by n. So therefore the order of both AB and BA are same, therefore we can define trace for both AB and BA. And fifth one, trace of identity matrix. Trace of identity matrix of order n will be equal to n. So that is, since 1 plus 1 plus etc plus 1, so this is n times. So if I is an identity matrix of order n, then there will be n ones in the leading diagonal. So therefore sum of these n ones will be equal to n. And sixth property, so trace of zero matrix. So trace of zero matrix is 0. So here 0 denotes zero matrix of some finite order. The seventh one is the cyclic property. Trace satisfies satisfies cyclic property. That is, if A, B and C are three matrices, then trace of ABC will be equal to trace of CAB. This will be equal to trace of BCA. And here note that, so if we take in any other order, so it will not be true. So that is trace of ABC and trace of some BAC, so this will not be equal. So this is not in cyclic order with respect to ABC. Another important property, trace of a matrix. So it's a property connecting trace of the matrix and eigenvalues of A. Trace of the matrix A will be equal to sum of the eigenvalues of A. So that is, if A is a matrix of order n by n, then A11 plus A22, so this will be equal to, the last entry, A n will be equal to sum of the eigenvalues. Suppose there are n eigenvalues, then lambda 1 lambda plus lambda 2, so this will be equal to lambda n. And the ninth property says about trace of a symmetric matrix. Trace of a symmetric matrix, trace of a various symmetric matrix. Trace of a symmetric matrix is real. So it can be seen that eigenvalues of a real symmetric matrix, we can omit this, trace of a symmetric matrix are real. So this implies trace of a symmetric matrix is real, and same holds for Hermitian also. So Hermitian also, same result holds for Hermitian matrix also. So you will see some examples. Okay, so how to find trace. So example, suppose if A is a matrix 1, 2, 3, 4, then trace of this A is sum of these eigenvalues. So sum of the eigenvalues are some of the diagonal entries. So diagonal entries are 1 and 4. So therefore trace of A is 1 plus 4 equal to 5. And suppose if B is equal to I5, there is 1 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 0 1 0 0 0 0 0 1 this trace of I5 is sum of the diagonal entries 1 plus 1 plus 1 plus 1, so we will get 5. So if you like the content of this video, so kindly share and like, and also if you need to get a future notification and future videos, so kindly subscribe our channel. Thank you.